गुड मॉर्निंग डियर स्टूडेंट ऑफ क्लास 9। आज मैं इस एग्जामिनेशन प्रिपरेशन का लास्ट वीडियो लेके आया हूँ। ये वीडियो है डेरिवेशन ऑफ एक्सप्रेशन रिलेटेड विथ वर्क डन एंड एनर्जी। तो चलो शुरू करते हैं वीडियो ऑफ derivation of expression of work done and energy. Question 1. Derive an expression for the potential energy of an object of mass m that has been raised to a height h from the ground. Answer. Consider an object of mass m raised to height h against gravity. Minimum force required to lift the object F is equal to weight of the body is equal to mg. Distance travelled by the object S is equal to h. Therefore, work done W is equal to F into S is equal to mgh. This work done against force of gravity is equal to the potential energy or gravitational potential energy of the object. This is potential energy is equal to mgh. Question 2. Derive expression for the kinetic energy. Answer. Consider a body of mass m lying at rest on a smooth floor. Let a force F be applied on the body so that body attains a velocity v after traveling a distance s. Therefore, work done is equal to W is equal to Fs. Since the velocity of the body changes from 0 to v, so the body is accelerated. Let A be the acceleration of the body, then according to Newton's second law of motion, F is equal to ma. Substituting the value of F is equal to ma in equation 1, we get W is equal to mas. Now using v square minus u square is equal to 2as, we get v square minus 0 is equal to 2s, or s is equal to v square upon 2a. Substituting the value of s from equation 3rd in equation 2, we get w is equal to ma into v square upon 2a is equal to half mv square. This work done is equal to the kinetic energy of the body. Therefore, kinetic energy Ke is equal to half mv square is equal to half mass of the body is or speed of the body square. Question 3. State and derive work energy theorem. Answer. According to work energy theorem, work done by a force on a body is equal to the change in kinetic energy of the body. अब बारी है derivation of work energy. Consider a body or an object of mass m moving with velocity u. Let a force F be applied on the body, and so that the velocity attained by the body after traveling a distance s is v. Work done by the force on the body is given by W is equal to Fs. Since velocity of the body changes so that the body is accelerated, let A be the acceleration of the body. Therefore, F, according to Newton's law of motion, F is equal to ma. Using equation 2 in equation 1, we get W is equal to mas. Now using v square minus u square is equal to 2as, we get s is equal to v square minus u square upon 2a. Using equation 4 in equation 3, we get W is equal to ma within bracket v square minus u square upon 2a is equal to half m within bracket v square minus u square, or W is equal to half mb square minus half mu square, or W is equal to final kinetic energy of the body minus initial kinetic energy of the body is equal to change in kinetic energy of the body. Thus, work done by a force on a body is equal to the change in kinetic energy of the body. This is known as work energy theorem. Question 4. State and prove the law of conservation of energy for a freely falling body. Answer. According to this law, energy can neither be created nor be destroyed, but can be changed from one form to another form. Now, derivation. Consider a body of mass m at a height h above the ground. Suppose the position of the body is A. Suppose the body at A is at rest, that is u is equal to 0. At position A, potential energy of the body Pe is equal to mgh, kinetic energy of the body Ke is equal to 0. Therefore, total energy is equal to potential energy plus kinetic energy is equal to mgh plus 0 is equal to mgh. Equation 1. Let the body falls freely under the action of gravity to position B through a height x. Now, the height of the body from the ground is equal to h minus x. At position B, potential energy of the body Pe is equal to mg within bracket h minus x. Kinetic energy is equal to half mv square, where v is the velocity of the body at position B. Calculation of v. We know v square minus u square is equal to 2gh. Here u is equal to 0. Since body at A is at rest and s is equal to x, therefore v square minus 0 is equal to 2gx, or v square is equal to gx. Put this value in equation 3. We get kinetic energy at position B is equal to half m into 2gx is equal to mgx. Total energy is equal to potential energy plus kinetic energy is equal to mg within bracket h minus x plus mgx is equal to mgh minus mgx plus mgx is equal to mgh. Finally, let the body just touches the ground at C, so that the distance through which it falls is equal to h. At position C, potential energy of the body PE is equal to mg. H is 0, so is equal to 0. Kinetic energy of the body KE is equal to half mv square, where v is the velocity of the body just at point C. Calculation of v. We know that v square minus u square is equal to 2gh. Here u is equal to 0 and s is equal to h. Therefore, from equation 7, v square minus 0 is equal to 2gh, or v square is equal to 2gh. Put this value in equation 6, we get kinetic energy of the body at C is equal to half m into 2gh is equal to mgh. Therefore, total energy of the body at C is equal to potential energy plus kinetic energy is equal to 0 plus mgh is equal to mgh. From equation 1, 5 and 8, it is clear that the total energy of a body at any instant during free fall of the body remains constant. Hence, the law of conservation of energy is verified. तो ये थे आपके इम्पॉर्टेंट डेरिवेशन ऑफ एनर्जी, वर्क एनर्जी। तो अब बारी है आपकी तैयारी की। तो एग्जामिनेशन के लिए तैयार हो जाओ। बेस्ट ऑफ लक।